Next is the Newton's first law of motion. What is a statement of Newton's first law of motion and how you can define it? So first of all, suppose that here is the football, and initially I suppose that this football is not moving. When this football is at rest, it remains at rest. And secondly, I suppose that this football is moving towards the right. This football is in motion. This object will continue its motion, but the object which is at rest, it remains at rest. I suppose that you apply the force on the first football, then what will happen? By applying the force, the object will move. It means that the state of the rest basically changes into the state of motion. When I apply the force on this football, this football basically starts moving. So I can simply say here, when the object is at rest, it remains at rest unless you apply a net force on that object. In the second case, the football is moving, and if I apply the force on that football, then both of the forces, like the direction in which the football is moving, this force and the force that I apply here, when both of these forces gets equal, in this case this football comes to rest. I can simply say that when you apply the force on this football, then this football basically comes to the rest. The object is in state of motion, continues to move unless you apply the net force on that football. This is basically according to the first law of motion. The object which is at the rest, it remains at the rest, but the object which is moving, it continues to move unless you apply the total resultant force on that object. You can see here the statement of the Newton's first law. A body at rest remains at rest, or a body moving with uniform velocity means that the body in the state of motion continues to move unless acted on by an unbalanced external force. Means that the total force is basically here unbalanced. There should be the total force which is acting on that object. It should not be equals to 0. If the balanced force is acting on the object, then the state of this object does not change. So I can simply say that when you apply the unbalanced external force on that object, then the state of the object changes. If the object is at rest, it starts moving, and if the object is moving, it comes to the rest. This is according to the Newton's first law of motion. Here is an explanation for that. If I suppose that there is an object which is at rest, and here is another object which is moving towards right. This object is in the state of motion. When I don't apply the force on both of these objects, they do not change their state. The object which is at rest, it remains at rest, and the object which is moving, it continues to move. After that, if I apply the force on both of these objects, the state of these objects changes. The object which is at rest, no, it will start moving, and the object which is in motion, it comes to the rest. This situation happens when I apply the force on these objects. The simple I can say, when you apply the force on the object, the state of the object changes. If it is at rest, it starts moving, and if it is in motion, it comes to the rest. So you can see here, if the net force acting on the object is 0, it means that no force acts on the object. Then in this case, the object remains at rest or continues its uniform motion. When the net force is non-zero, means that you apply the force on that object. The net force is not 0, it is also be called as the unbalanced force. When the unbalanced force is acting on the object, then what will happen? The speed or the direction of the object changes. You know that when the unbalanced force acts on the object, it causes the change in magnitude of velocity or the direction of that velocity. It means that the resultant force changes the velocity of the object, causing the body to accelerate. When you apply the force on any body, it basically accelerates. That's why by applying the resultant force on the body, I can simply say that there would be the change in the velocity of the body. When the velocity of the body changes, of course, there would be the acceleration. And the Newton's first law of motion is basically also be called as the law of inertia. First of all, you have to know about the term what is meant by inertia. Inertia is basically the property of a body to maintain its state. Means that if the body is at rest, it remains at rest. And if the body is in motion, it continues motion. The ability of the body to maintain this state of rest or motion is basically called as its inertia. And in the Newton's first law, we see the same thing. If we don't apply the force on the object, then it maintains its state. That's why the Newton's first law of motion is also be called as the law of inertia. The same thing is given here because the Newton's first law of motion is concerned with the inertial property of a matter, which is the maintenance of the state. That's why it is called the law of inertia. Here you can see the definition of the inertia. Inertia is the ability of a body to maintain its state of rest or uniform motion. For example, if I suppose that here is a table and I place any book on this table, then this book basically remains at the rest because this book cannot move unless I apply the force on that. It means that it is basically the property of that book which is called as inertia. Due to the inertia, this book maintains its the state of rest. The same thing is given here. For example, a book on a table remains at rest as long as no net force acts on it. Means that when you don't apply the net force on that book, it remains at rest. Here you can see there is only the force that can stop the moving object or can start its motion. Means that when you apply the force on the object, if the object is at rest, it starts moving, and if it is in the motion, it can stop. Here the hurdles basically shown here. Because of these hurdles basically applying the force on the object, that's why this ball stops. Means that these hurdles applying the force on the ball, due to which its state of motion changes into the state of rest. So I can simply say that the force can changes the state of the object, means that the force can stop the moving object. After that, when this person applies the force on the ball, then the ball starts moving. It means that force can move the stationary object. See, this is the application of the Newton's first law. Initially, the object is at rest. When this person applies the force on this book by his feet, then this book starts moving. So I can simply say that when you apply the force on the object, only in this case the state of the rest changes into the motion. You can see here there is a simulation related to the Newton's first law. Let's open this. You can see here there is a bus, and when I press this button, basically here I am applying the force on it. So when I press this, I apply the force. First of all, initially the bus is moving. No, it comes to the stop. Again, I press this button. The bus which is at rest, it start moving. So I can simply say here, when I apply the force on the object, only in this case, the state of the motion changes. Means that if the object is in motion, it comes to the stop. And when the object is At rest, it's start motion. The same thing you can see here, it's basically the application of Newton's first law. Here is the exam question that appeared in 2021. Let's see this. A car travels forward along a straight horizontal road. Only the horizontal forces acting on the car as shown. See this car, there are two forces acting on it. One is the driving force and the second one is air resistance and the frictional force. Both of these are acting in the opposite direction. The length of each arrow represents the size of the force. You can see the length of this arrow. They basically represents the magnitude of the forces. Which statement describes the effect of these forces on the motion of the car? Let's see the answer. Answer A. The car moves at the constant speed. B. The car starts to move backwards. C. The car slows down. D. The car's forward speed increases. First of all, you have to tell that which option is correct from here. Let's see the figure. See here the magnitude of the forces. The driving force has a magnitude of smaller length. Here there is a driving force whose magnitude is smaller because its length of the arrow is smaller than the length of the arrow in the air resistance and frictional force. It means that here the air resistance is larger as compared to the driving force. When the air resistance is larger than the driving force, first of all, you have to understand what is the effect of the air resistance and the friction. Both of these act in the opposite direction to the motion of the car and they actually slows down the car. It means that when the air resistance and frictional force has larger magnitude than the driving force, this car slows down. It cannot speed up. The car only speeds up when the driving force is larger than the air resistance and the friction. Let's see the answer and explanation. So here it's given that as the force due to the air resistance and the friction has greater magnitude, because for both of these forces the length of the arrow is larger than the driving force, the car will slow down. So when the air resistance and friction is larger than the driving force, the car basically slows down. Answer A and D, both of these are incorrect. Let's see the answer A and D. In the A, the car is moving at the constant speed. In the D, the car's forward speed increases. So answer A and D, both of these are incorrect because the car's speed decreases. The car slows down due to the air resistance and the friction. Answer B is incorrect because the driving force is forward. So the car will not move in backward direction. It has to move in the forward direction. That's why the correct answer is C. Let's see the correct answer, which is C. In the answer C, the car slows down. So this is the correct answer because here the air resistance and frictional force is larger than the driving force. That's why the car slows down.